We are discussing about the given topics. First one is Prim's algorithm. Prim's algorithm comes under a greedy algorithm. User discover the minimum spanning tree from a given tree. Executing Prim's algorithm, set up the minimum spanning tree using a random chosen vertex. Find the minimum of all edges connecting to tree. Further vertices, then add it to the process. Repeat the step 2 as necessary to obtain minimum spanning tree. Let us see one by one to understand clearly. Here is the given graph. First select a arbitrary vertex or any vertex you want. Here selecting R. Now I connected R to the Q because of its least waste. Then from Q you can see P is connected, R is already connected. So we connect the so we so we connect connect the edge. Here we take in T and R connection, and the next step we connected T with U. In the next step we connected P and R, which are nearest edges to the R. See algorithm to clarity. Step 1, choosing a vertex. Repetition 3 and 4. Choose an edge with minimum weight that connects 3 vertex to the single vertex. Step 4, include the chosen vertex edge in the list spanning tree. Finish exist. Its complexity is E log V. Its applications are electric wire installation and design networks. Here is the code and output. Let us discuss about the Kruskal algorithm. Kruskal algorithm is also a minimum spanning tree algorithm for a connected weighted edges. Kruskal algorithm is preferred to find the shortest spanning tree. The major goal of Kruskal algorithm is to encounter a subset edges that may be utilized at every vertex of the graph. It pursues the greedy technique. First, we will focus on sorting of all edges and sort them according to their weight. Now we will pick the edges have the least amount of weight and associate it with spanning tree. If the edges have been forms a cycle, it should be rejected. So let us discuss one example. Here is the given graph. Step 1, select any one vertex with the minimum weight. Here OPQ having 1, select it, and then next one is TS, select it, and next one from S, from P and Q we again come back, and Q has the nearest vertex QR 3, then we connect it. From R4 and S we connect it. Then again we go back to P. It forms an edges with the nearest vertex, so we dump all. Here is the steps I mentioned. You can see that PT having a cycle, PR having cycle, PS having cycle. So we dumped all this. The total value is PQ plus ST plus QR plus RS is equal to 1 plus 2 plus 3 is equal to 10. Let us see algorithm. Phase 1, construct a forest F with each vertex graph representing a distinct tree. Make a subset E that holds all of the graph edges. Step 4 and 5 should be repeated until E is not vacant and F is not spanning. Exactly an edge from E with the least weight. Step 5, add the edge generated in phase 4 to the forest F to join two different trees for mixing two solitary trees. Else we dump the vertex. Step 9 is to finish. Here let us see. Here is the code, and here is its output. Let us discuss application. The technique by Kruskal can be used to build electrical wire across cities. It is possible to operate set up LAN accounts. The complexity is order of E log V or order of V log V. Let us discuss about the single shortest path algorithm in greedy. In context of the greedies method, Dijkstra algorithm is most commonly used to solve the single source shortest path problem for the graph with a non-negative edges. Let us see the algorithm. Step 1 is initialize the distances. Set the distances from the source vertex itself 0. Sets the distance for all other vertices infinity. Step 2, mark all vertices unvisited. Step 3, extract the vertex with the minimum distance. Step 4, relaxation. For each unvisited neighbor UV, calculate the tentative distance. Step 5, repeat the 3 and 4 until all vertices are processed. Here is the diagram you can see. Here is the process. that are defined. The shortest path A to B is distance 1, B A to C. Distance 4, A to D is A to B or B to D. Distance is 3. Networking routing, we can use this application. Here is the code and output.